That's it. So we really put those fields to public access modifier, so everyone can access it. And we have two methods. In the slides you have seen many behaviors, but we only write two methods. That's it for simplification. So that's our class. So how to write a class? Let me write it again so that you can understand. Write class and the class name. In this case, person maybe 2 is a person class. And let's write the properties. Public, and in this case these are the fields, not properties. Don't confuse the properties with fields. Try to remember that these are the properties. We're going to talk about these are the fields, and we're going to talk about the properties later on. So string, first name, let's say, just, and to write a method, what, and define the method. That's it. So that's how you're going to create a class. This is it. So a class should be, one class should be in one class file, but you can write multiple class in one CS file, but it's not really recommended. The best practice is to put your other classes or interfaces into separate files. This way you could find your classes very easily, and the best way is to keep your class name as your C# file name. So in this case the C# file name is person, so I write my class name is person. If you go to the program, this has a class name of program, like this. So this is the best convention, but you could write whatever you want. It will not complain and it will run just fine. So that's it. So we have seen the class. Let's see an instantiation of the class. So person, you could write anything. You don't have to write only the person, but for simplification I'm just writing the object name as person. That's it. And new, like this. So to change the first name, I just go to the first name and say that first name is Elias. That's it. For now, that's it. And let's say that I tell my person to walk, and let's see what's happening. Elias is walking. That's it. It happens like this because I have a console.writeLine method in the walk method. As you can see, it's very simple, nothing complex here. So that's how you instantiate an object from a class, and then you manipulate the object by accessing the properties or calling a method. To call a method, you whenever you see in a programming language, in most popular programming language, this parentheses is, you have to understand that this is a method. So it's a method, logic, or behavior, what we have discussed earlier. So that's it. And let's go to our slides now. So let's see a class constructor, because a class, when a class is created, the constructor is the first method that is invoked. A class could have 0 or multiple constructor. Even though a class doesn't have a constructor, it will call the constructor implicitly. So constructor is always called. Whenever you call new, then person, the constructor is implicitly called, even though there is no constructor. When you write a constructor, it is explicitly called. So let's see some examples of constructor encoding. So here I am in the Visual Studio. We are going to the person class. To write the constructor, what you can do is write a public and then write the same name as your class name. That's your constructor. the exact name as your class name. That's your constructor. So you can have 0 or multiple constructor. We're going to talk about multiple constructor later, but you can have multiple constructor by overloading method. We're not going to talk about overloading right now. We're going to talk about overloading later. So when we talk about overloading, you'll understand that how you can create multiple constructors. And you could do something like this. You are initiating let's say an array or something like that. Whatever this type of object you do, work you do, you can do it in the constructor section. So let's just go very simple and write line that a person is created. Person is created with name. Let's see that what happens to the name. So first name, that's it. So let's run the code. We don't need any change in our code. So whenever we call the person, the person is created method is executed, but the person name is really empty, so it really doesn't show anything. We really go to the code, it's really empty string, null string, so it doesn't show anything. So it only shows those two console write lines because this was the first one executed and the next executed when the walk method is called. That's it. It's very simple, not complicated. So another thing about the constructor, in Visual Studio you could write constructor very easily. If you write ctor and hit tab, you will have your constructor. That's it. So let's just delete those lines because we are not really interested in the constructor of a person right now. Let's go to our slides. So let's see how to create a destructor. A destructor is used to clean up your memory or to make your application more efficient. But luckily for C#, if you have any memory leaks or memory problems, the garbage collector will kicks in time to time and clean up your memory. You really don't have to do this, but sometimes it's really a good practice to use the destructor. And when you have a huge list of items, it's really a good practice to remove it in the destructor. So let's see how to create a destructor in a class. So let me switch over to Visual Studio. Here I'm in the Visual Studio. We could go to our person class, and I have separated my person class with those regions. I really like to separate my codes and like to use the regions, and you could separate your codes like regions. I will show you. You could do it by Ctrl K and then S. Then you go to Visual Studio and go to region, and then I'm going to say that destructor, because you can have only one or zero destructor. To write a destructor, you have to put the tilde sign. I call it tilde sign. I really don't know that what it's called, but really remember that it's really called the tilde sign. So whatever it is, put this and then write your class name. And that's it. That's your destructor. So if you have a huge list, you should clean up your list, but for now we're going to just print out that destructor is called. That's it. So let's really run the program and let's see what happened. And I'm pretty sure the destructor will not be called. So or did I make mistake? Okay, so that's it. Destructor is not called. So destructor, why is not called? Because my person is not destroyed. So let's really destroy it by setting it to null, because it doesn't have any memory reference to it. So a garbage collector will kicks in and destroy it at some point, and this is when the classes destructor will be called. But for C#, if we run this, you will not see this happen right away. To do this happen right away, what you can do is call the garbage collector, write GC is the garbage collector, and say collect. That's it. And now if I run my code, I'll see that destructor is called. Now let's see some complex scenarios. Not really complex, just the simple scenarios, but now I'm going to go break some rules that I have said earlier, but that's just for the convenience of file for this demonstration, but it's not the right way to do the work that we have discussed earlier. And I have so many files in my project, and we're going to include one by one as we need those. So we're going to include the destructor class, and here I have introduced two classes in one file. It's just because that it's just a demo purpose, but on a professional project you shouldn't do that. So here I have a simple destructor class, and then I'm just going to comment out this portion because we are not there yet. We have really a list where we have created, we make a capacity of 2000. If you know the list objects, it already creates the 2000 elements or array in the memory heap. So at the end of it, I'm going to set the list to null so that it wouldn't take any more memory at the heap. And then I'm calling the destructor. It will be same as before, but this time the method will be different, and we're really cleaning up something. It's not really very fancy, but let's just do it. Destructor class. Oh, let's see. So let's show you something else. Here we are doing the person, and then we're saying that the object name. So the first thing you define is your data type. So a person is a data type. Whenever you make a class, it's a data type, and a class's discrete name is data structure. So whenever you see that it is about data structure, you have to understand that it's about class, but in very detailed manner. That's it. So what you can do as a C# programming, write var. So you have to really understand the var. var is like I'm really too lazy to figure out the type. So what happens is at the compile time, var is compiled to person. The person will be replaced into the var. You cannot write like p. That's it. If you compile it, you'll get an error. That's this. So let's just do it very quick. Yeah, that you cannot compile it because you're implicitly defining a thing, but you're not defining that what the thing would be. So it's really giving you an error. So at the compile time, the compiler doesn't know that what type it should put. So that's it for var. And there is also a dynamic data type.